Hello, welcome back to the channel. So let's do a mixed problem which includes infinity and minus infinity as endpoints and also has discontinuities which lie in between the definite integral specified. So now you can clearly see that in this function over here, your function is not defined at x equals 2 and also it's not defined at x equals 0 in this case, right? And also you have infinity and minus infinity as endpoints, so you'll have to deal with these endpoints as well in order to solve this definite integral over here, right? So we'll cover all the concepts that we covered in the last videos on improper integrals. So I'll highly suggest you to first watch my previous videos in order to get the full context of this video over here. So now we know that we'll have to break this definite integral into multiple parts in order to get the solution to this definite integral over here, right? So now let's first start by splitting this definite integral based on these 2 points over here, right? And by using all the concepts that we covered in the previous videos, we can split this definite integral for these points by writing the definite integral as simply minus infinity to 0 plus, so I'll not write the function over here. This is basically a rough work which will help us understand how we split this integral in order to solve this question over here. So in order to split this integral using the points of discontinuities, this integral will basically be integral minus infinity to 0 plus integral 0 to 2, right? Plus integral 2 to infinity over here, right? So now we are done with the first split, but we still have to do multiple splits after this in order to simplify this definite integral over here. As you can clearly see in this definite integral interval case that you have two discontinuities in the definite integrals. So we'll have to split this definite integral such that we have one discontinuity at only one of the endpoints, right? So what we'll do is we'll introduce a new variable. Let's suppose a, which lies in between 2 and 0. So this is what we are doing based on the previous concepts that we learned, right? And we can split this definite integral as simply minus infinity to 0 plus 0 to a, because our a lies in between 0 and 2 and we don't have any discontinuity between 0 and 2 over here, right? So plus 0 to a plus a to 2 plus 2 to infinity, and that's it, right? So now our second split is done, but still we have to do more splits in order to simplify this definite integral over here. Because in this case, we have minus infinity and 0, which are two discontinuities, and over here as well, it's the same case. So we'll have to split these two definite integral expressions as well, right? In order to get the perfect simplified version for our definite integral calculation. And the way we'll do that is we'll introduce two new variables over here. So we'll introduce a new variable which is b, which lies between minus infinity and 0, and we'll introduce another variable c which lies in between infinity and 2, right? And the way we'll split this integral is we'll basically split the minus infinity to 0 integral as basically minus infinity to b plus b to 0, and the other two integrals will be the same, so 0 to a plus a to 2 plus, and the integral from 2 to infinity will be split up into two parts again by using the same approach. It would be basically integral 2 to c plus integral c to infinity over here. And now you can clearly notice in this definite integral split that for each definite integral, if you have a discontinuity, the discontinuity is only based on one endpoint over here, right? Like in this case that you have minus infinity over here 0, and over here 2's, and over here your infinity in this case, right? So now this is the final split, and now we can proceed on adding the function into the definite integral expression in order to solve this definite integral over here, right? So now since your function is basically dx upon x minus 2x square, you can write the final expression which would be basically minus infinity to b dx upon x minus 2 times x square, b to 0 dx upon x minus 2 x square, 0 to a dx upon x minus 2 x square plus e to 2 2 to c and then the last one is from c to infinity. And now you can easily solve for these definite integrals separately in order to get the final solution to this definite integral over here. So we'll not do the definite integral calculation part because we have already covered those concepts in the previous videos. You know that you can easily solve these definite integrals using partial fractions, right? Because you know that if you have factored out terms in the denominator, you can easily split this expression by using partial fractions. If you want a hint to solve this question, you can split 1 by x square, because your function is 1 by x square times x minus 2. You can easily split this function as simply a upon x plus b upon x square plus c upon x minus 2 in this case, in order to simplify this expression into 3 individual parts for which you already know the integral for. So that's it for this video. Again, the main takeaway from this video was to split our definite integral based on all the discontinuities and get the final expression, get the final simplified expression at the last, which only has at most one discontinuity for each definite integral, for each individual definite integral over here. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.